You're listening to Within Tolerance, a podcast for machinists by a machinist. I'm your host, Dylan Jackson from Protea Machining. And this week, I'm very happy to welcome Matt Hertel from Pocket NC. Welcome, Matt.
Hey, how are you, Dylan?
I'm doing well. So before we jump into your backstory, what is Pocket NC? What do you guys do? I mean, I feel like at this point, everybody's got to know the Pocket NC name, but just in case, what do you guys do? What do you make? All that good stuff.
Yeah, right. So Pocket NC is a company that makes small machine tools and little 5-axis ones. They were kind of designed to fit on your desktop. We started that making those about the time that 3D printers were getting popular. And Michelle was working at Boeing and I was working at a supplier for Boeing. And we just decided to kind of get in on that because it was something we both felt like we could be passionate about. So yeah, they're little 5-axis milling machines. And I guess if you're not familiar with machining by now, I don't know, but yeah.
Yeah, definitely. Well, I definitely want to get into your backstory because I was listening. You guys had a great interview on the DFX podcast, maybe a couple years ago or something like that.
Yeah.
And that kind of got into the backstory of Pocket NC, but you guys kind of just glossed over, oh yeah, Matt has some machining background. So I want to get into, how did you get into manufacturing and get to where you guys are now?
Yeah, in high school we had some like a Bridgeport or like an off-brand Bridgeport. I don't quite recall. I don't remember all those names, but there was a lot of lookalikes. And then so I got kind of hooked on it there. And after some messing about with an electrical engineering degree, I decided to go into machining at a trade school out in Helena, Montana, which is our capital. And yeah, I really liked it. I really enjoyed it. And it was all manual for the first year. And then the second year got into the CNC side of things. That was fun and scary, exciting. But like you could make all these things. And we trained with, it was like all high-speed steel, and oftentimes we had to grind our own turning tools for our lathes. And my lathe actually had a leather belt on it, and it was like it would always loosen up. So it was an old what was that, Clausing? It was really accurate. It was awesome, but that damn leather belt would always stretch out, and the little staples would come out. And so you'd like, I look over one time, and my buddy was on a matching Clausing, and he was like, it was so ridiculous. He was pushing the belt with his hand like a giant sewing machine or something like that, because his belt just loosened up. Anyway, so yeah, that was kind of it. I got into it there, and then I went to work for a company called Electro Impact out in Washington, which was just such a great experience. I think like working anywhere, it has its good and its bad, but the good was just that like, here's a company who they really believed in people like making their own stuff and putting their own stuff together, and they just made amazing engineers and machinists that way. That there was so much prototype work. We rarely made it more than 10 parts of anything, but usually it was like 1 to 3 parts. And so that was just the prototyping work is just like, the experience is just second to none,
Oh yeah, that's the world I live in. So I totally understand.
Right. Your brain is just always having to solve these problems. So I was really fortunate to get to do that. And then so at about that time, MakerBot was coming out with their machine, and we were talking about, I think it was the Thingomatic is what it was. Yeah, and I'd seen the Cupcake prior, Cupcake machine. But anyway, we started to talk about making one for just like home projects and stuff. And then at one point we're like, what if we started to design our own that we could sell to people? And that was super naive. Like it's so much work, but working at Electro Impact was cool because they would let you prototype your own stuff using their tools, materials. So I could use all their end mills, and they would actually let me use their aluminum that I could just carve up a piece on the floor. It was no big deal to them. And
that's
and
amazing.
Also, yeah, I know, it's unreal. And then they also had access to SolidWorks and Mastercam, right? So I could use. I had just free access to all this stuff. So Michelle and I would go in at like crazy hours, like on a Friday night. So there was a night shift during the week, but starting Friday night, you could go in and start at 10, I think it was, and we'd work till like 2 to 4 in the morning on the project
Yeah.
and prototyping, and then we'd both be too tired and we'd bail.
The
We
first
would,
shop I worked in was
yeah,
very similar. Like that, nobody else took advantage of it, but my boss was totally fine with me, grabbing some scrap aluminum and
yeah,
spending an hour or two after work every day, working on whatever I wanted. And I think I think shops don't realize the opportunity that provides. They only see the downside. They're like, oh, well, you could scrap the machine or you could break a spindle or whatever. It's like, yeah, but there's so much learning that you do when it's your own project and you like want to
oh,
do it right. And like, you want to like iterate and all that. And I really, I love that opportunity. That's so cool that you guys had that too.
yeah. It was huge. So yeah, I took advantage of that. Then we moved out to Montana. We moved into my parents' basement, and I didn't do much machining between then and until we launched or got close to launching our Kickstarter campaign. We realized we needed to do a few more prototypes, and we ponied up on a Haas mini mill and put that in our garage. And Michelle's
Very
so
cool.
funny. Yeah, so it's like you have all this experience with machining and everything, and Michelle's like very type A. So she went in and she just like started reading the Haas manual, which I don't think most people do. And I'd be like, I don't know why you're doing that, but I didn't want to like put her down because I just figured I knew it all.
Right.
And then she'd come and be like, did you know you could do this on the machine? I'd be like, no, I had no idea. Yeah, let me see what you're doing. And then she'd like run through how you do it and stuff, and like so all of that was just amazing. And then yeah, but that's kind of where the machining, that's pretty much my past. It's not, I didn't work at a ton of shops.
What did the shop
Yeah.
you worked at had as far as machinery goes? Was it all 3 axis or?
Yeah, that was crazy. So they didn't have I want to say they didn't have very good machines, but depending on just how you look at it, I would say. So they had a lot of like these Bridgeport machines, but they were like the knockoff machine. Here's a company that has like they do just like world class stuff, and they did for some of the production stuff have DMG machines. But then for all like the prototyping, it was just all these Bridgeports with Accurate control. I don't know if have you ever seen those, Tone?
Yeah, I've never
Yeah.
used one actually, but my last guest, Alex Kern, was also talking about that's how they
Yeah.
started their instrument division. Was like, or when he came back, they had one of those as well. So that's really
Yeah.
interesting to hear it come up again.
They were incredibly fast. You could just do so much on them. I'm kind of drawing some blanks on what about it was, because it's 10 years ago now. But
Oh, actually, I saw your post, by the way. Congrats on 10 years of
oh,
Pocket MC.
yeah. Oh, thank you so much. No, that was Michelle and I got married 10 years ago. And wait, is that what you're talking about? Is our
Oh, I didn't know. Is it your anniversary?
Yeah, sorry, I should have said that. I should have specifically said anniversary.
I thought it was your anniversary of Pocket NC. I didn't realize
no,
it was.
who knows when that is. Like we started it so many years before we actually launched it. Yeah, no, that was yesterday was our 10-year anniversary.
Oh, well then,
so,
yes, happy anniversary. Very
thanks.
cool. But so the reason I was asking
Yeah.
about the machinery is, where did the idea to make a horizontal desktop 5-axis come from? Because I feel like anybody who had only access to maybe 3-axis mills in the past would have looked at the problem of making a desktop 5-axis and been like, well, clearly I make a vertical AC 5-axis, call it a day. This is a tried and true C frame. Go from there. So how did you come to that decision?
Yeah, when we're so that we kind of, I don't remember how we ended up on the size. Oh, no, I do remember. Okay, so the size of the machine was based around the diameter of the tooling, and we figured that the machine was going to be mostly used with 1/8-inch shank tooling, which has a pretty short maximum reach, right? And until like recently, when Datron started coming out with some amazing single flute, longer reach tools, right, with a 1/4-inch shank and then or 6 mm shank and then reduced. But yeah, so we've kind of built it. We built the size of the work envelope around the tool that we figured there's no sense in going too big, and that for better or for worse, right? Obviously, people need work holding and stuff, so there's some stuff in hindsight that we could have done better on. But yeah, and then so my night shift manager, Gary, him and I would just spend so much time talking about like how would you make this thing so that somebody could actually set it up? And you like, do you 3D print much, Dylan, or
Yeah.
ever? Yeah,
Oh
yeah.
yeah, yeah. I'm looking at my 3D printer, and then I'm currently, man, I'm like a couple $100 of worth of parts away from starting to build my Voron. So I'm
Oh,
definitely into it.
okay, you're like all in. So the like on some of those old 3D printers, especially, there's like no room to get your hands in there or do any right. And we were just like, this is a problem with small machines. Is how do you like you have no clearance or way to get, and your hands are big. Like you're trying to do all this stuff in these tight little areas. And we're so eventually we ended up with that horizontal design, and we're like, this will give people, top front access to setting up their parts, and they'll give them like a good visual area. And that was kind of how we settled on it. And then from there, it just worked on the concept of how do you get all the motion and fit it, all the motors and everything in there.
Okay. Yeah, that totally makes sense. That's it. It's such a cool design because I feel like you gain a lot of rigidity as well by not having a tiny C frame that probably would have been weak anyway.
Yeah, yeah, maybe that was how we planned it, right? Yeah,
Yeah,
no, we
yeah,
just
yeah.
yeah, no, we did. I mean, it's funny how you look back and you're like, oh, that was good, or oh, that was a total crap move. So yeah, that was, I guess, maybe a little bit lucky. It's hard to say, after all these years, how much of it was really thought through and how much of it was luck.
Luck. Okay. Well, so you mentioned kind of bad decisions as well. I've noticed that when machinists buy tooling or really anything, we are the best in the world at finding the weak points at things.
Totally.
So after you released your first round of V1s, what were the things that surprised you that came back as like, oh, this is not working, or this broke really quickly, or how did people destroy your baby in ways that you didn't expect?
We tried to make that machine as low cost as we possibly could. So we loaded it with weak points. Like just even the belt we chose, it was able to absorb oil. So people who use WD-40 and stuff like that, that belt just absorbed it and became a giant break on the machine. And so like
Oh no.
people would be like, oh, our rotary axes are binding up. What's the deal here? And pretty quickly we got down to the bottom of that. And then, a weak point is putting all the electronics in the machine. We're moving away from that because, you just, you're making tiny little bits of metal shavings, right? Like the most ideal way to ruin something is by like you look at about satellites and tin whiskers, but or
Yeah,
like
yeah, I love
yeah,
that.
yeah. And so these tin whiskers grow on things, and it's like here you have a little tiny piece of metal, and it's just traveling out into space, shorting things out, and that's like here's a machine that makes the little tiny shavings of metal, right? And it's just like a matter of time before that fails. And then the I feel like the biggest one of the biggest design flaws that was just like we should have known better was we put that dumb little yellow button on the side of it just to save money. Like we're like we need a stop button on this machine, but we shouldn't have gone low cost on that because it just wasn't as reliable as you might like you really need your cycle start and feed hold buttons to be like as reliable as possible. But the funny thing is we still have people like cranking on their V1s, and it's like this every once in a while somebody calls in and they're like, hey, I'm having this problem with our V1. And we're like, oh my. And they talk about all the parts that they've made on criminy. People find workarounds. They make the people that want to make it work, holy moly, they made it work. So yeah.
Right. So then going to the V2, besides
Yeah.
the spindle, you guys went from what, 10K to 50K?
Yeah. I mean, so you're right. So we increased the motor. We mostly were looking for like increased torque and on a couple different things. And then the high RPM was just that little tiny spindle it was okay with 10K, but it had so much more potential. And there was a lot of people who were like, I just need to be able to make stuff faster. And as a little side note, most of our, like only 1% of our machine buyers ended up being hobbyists, less than 1%. It was all these people prototyping, doing R&D stuff.
Oh, really?
And
That's
yeah,
cool.
so they didn't really have a budget, which was very interesting. We'd sold a bunch of machines to Gillette and like DuPont and NASA and stuff. And it
Oh
was
wow.
like they didn't care so much about budget, but they just needed a machine that would work for their application. Here's people like, you're never going to go give just some random engineer access to the good machines in your shop because
Right.
you're not going to have a shop.
Yeah,
And so
especially a 5-axis. You're not gonna be
yeah,
like, oh, here's a Harmley or here's a
oh my
DMG or
god,
something.
yeah,
Like,
right.
have fun.
Right. uh yeah, they're just, yeah. So I mean, but that's just how it happens. And so that machine ended up being perfect for all these, grad students and people prototyping that they're like they had to wait so long to make their parts. They would get these machines, and so naturally they were just like, oh, 50. Is there a way we can get more RPM so we can make things faster, and it cost us just not an issue. And so naturally it just progressed into that direction of better equipment. Yeah.
Okay. And then so what else was changed? Like what lessons did you learn in V1 that you also applied to V2?
Just a lot of how the parts were manufactured. Like there's a lot of probing and checking on parts and how they're made, just to make sure they come out right. And it kind of helps with the start of the process. If you're putting together a machine that the parts are no good, the machine's going to have problems. So that was a big step forward, is how we made our parts. And then we learned a lot of lessons in the electronics and how we built those, and just where some of the failures were. So that there were a ton of changes there, and things are always progressing along that line. But then, the first machine was belt driven, and we were using stepper motors in tandem. And stepper motors are great for a lot of things, but in CNC, they can be great if they're used in their most ideal situations, but very quickly you step outside of their limits. So with the V2, we're still using stepper motors, but we tried to really like tune things for the stepper motors so that they could be ideal. So like we didn't go any faster on we didn't increase our speeds on travel and stuff. But like with the rotary axes, we instead of doing the belt drive, like I was talking about, we switched to using a worm gear drive, which was really nice. But that was a process because we kind of had to make our own worm gears. So we had to make a small machine that you load in, injection molded blank, and then we use a special hobbing tool and cut that, with servo motors and stuff. It's just like
That's
took a
cool.
while. Yeah. So that was probably some of the big improvements there.
At that point, did you
Yeah.
guys? This might be a great time to talk about what machinery you guys have internally to make all these machines. At that point, did you guys have your 5-axis?
Yeah, somewhere maybe, I don't know if it was right before. It must have been right before we started making the V2. We were close to it. We bought a UMC 750, and that was a big improvement for us. That at one point in time we had moved from just doing 3-axis machining on all our parts, and so you have 6 sides per parts, to a 4th axis, and it took a ton. I mean, like overnight allowed us to double our production, which was amazing. And then when we moved to the 5-axis, there were similar improvements, but on top of that, we were still able to reduce some of our errors that we had by taking
it all at once.
the human. Yeah, right. Yeah, instead of flipping it and messing things up.
Listening to your interview with Ed, I like the irony that was not lost on me that you're like, oh yeah, we're building a 5-axis machine, but we're doing like 9 ops in our mini mill, making V1. And I was like, yeah, that's rough. That's really rough.
It was, yeah, it had its moments of frustration for sure. Yeah. And so now we had the UMC 750 for actually quite a few years, and we built on some automation to it. And then eventually we did sell it, and we bought a Doosan. The Haas is really, really great for getting going, but we sort of have been on that. We've just been pushing it for what it's capable tolerance wise. And so we bought a Doosan DVF 5000, and then we pushed the automation and improved it over to that and sold off the UMC 750. But then we bought a UMC 1000 for just prototyping stuff, and that's been pretty good. But it probably struggles a little bit more than the UMC 750 did on tolerances because of the
Just bigger
uh,
travels and everything.
yeah, I think so. And they, they redid the and it's a company that's learning as well, right? How to make stuff, and they do really well by serving people in a certain accuracy class, and they do it well. And so naturally, if you're trying to push the limits of things, or like I mean, like a DMG machine is going to struggle beyond 2/10,000s, right? So if like your goal is to be above 2/10,000s, well, you probably have the wrong machine for your finishing ups, right? It's just
Right.
not. There's only so much they're capable of, and shame on you for trying to push it more than you can consistently do. So that's kind of what we have for machines for now, and it's good. I hate the control on it so much.
Is it Fanic or is it
It's a
Heidenheim?
Fanic.
Okay.
It's a yeah, and I'm like I grew up on the Haas control, which they did great with, and is super. And it's like 3 button presses to every 1 button press. It seems like on the Haas. So that was maybe a little bit of a mistake. The machine itself is so accurate and consistent, and we love just about everything about the machine, but God, I hate using it. So I just like every time because we set it up for automation, so everything's very like consistent and stuff, and you almost never have to tamper with anything. But then when you do, and it's like I feel like I'm learning something all over again because I just don't use the control day in and day out. And it's such a whiner thing to say, but like
no, I totally understand.
yeah.
I was just talking to a friend recently, and I can't remember how it came up, but he was like, "Oh, are you thinking about Matsura?" Because we're looking at a 5-axis possibly for our next machine.
Yeah.
And I was like, no,
Matsura being the main focus, or
no. So he had asked me that, and I said, no, definitely not. And he's like, well, why? Like, you love Yamazin, But I was like, if I'm spending 5-axis money, I don't want a Fanic. Like that is really what it comes down to.
Yeah.
I hear you, and I totally understand.
Yeah, we did have some weird issues, like engraving. You would have never guessed, but engraving seems almost nearly impossible on the Doosan, which
really
blows. Yeah, and you can do it, but I mean, like, so John, our software engineer, he's like an XtremeWorks guy. He's so dang smart, and so everything he does is like math-based animation and everything. He's awesome software engineer. That is the only thing I have seen foul him up is how to engrave on that machine. I mean, this guy writes new G code programs all the time, like routines and stuff. He understands G code to its core. I've never met anybody who understands G code like John understands G code, and it would just like he was struggling.
Wow.
So, and in the end, we were able to do some engraving on some of our parts. Like this is one thing that we did that was really great on the UMC 750 when we were running our automation. All of our parts had like serial numbers and tolerance bands on them and stuff. And then when we moved over to the Doosan, the tolerances were significantly better, so we didn't have as many of those problems, and we didn't have to check on batches and stuff. But good night, you're not gonna like be able to track it by its part numbers because like we just physically could not master that.
It just wouldn't look good, or what was the issue? Like, what would happen when you guys were trying to engrave?
Yeah, it's just we couldn't figure it out. Like you have to do all these weird letter calling stuff. I'm gonna mess it up. I'm not even gonna try. But yeah, I quit and let those guys try to figure it out, and they got it on the parts that absolutely mattered. And beyond that, they just let it go. So yeah, I know it was terrible. And then there's also some things like, it was really difficult for the Doosan people to figure out how to, like every time we load a face mill, it chips the inserts on the face mill because the RPM's too high on the probing routine. Yeah, and they can't. To this day, they couldn't figure out how to change it in the Fanic control, and it's not for a lack of trying. I think it's just they really struggled working with Doosan and between the Doosan people and the Fanic people to get that figured out. So to this day, we still set our face mill off of a known height, like a gauge block. And yeah, it's wild though. And so, but I think that's kind of the Fanic control is just so, outdated. Yeah. Right. So sorry. So what are you looking at, Dylan, for machines then? What do you think you'll get?
We're not sure yet. Like, I'd love like a Kern, or I'd love, some super expensive machine, but it's like, it's like, I don't have, close to $1 million to spend. So right now on the short list, we're possibly looking at like a Hermle C250. because
Yeah.
those come in right around actually the Doosan price as well, or at least a fully kitted Doosan, I guess I should say. But that's on our mind possibly because there's pretty good Hermley support in Phoenix, so pretty local. Whether or not we can get one, we'll see. It sounds like there's some companies in Arizona buying up a ton of Hermleys, making supply kind of short. So yeah, we're not sure. We're gonna go to IMTS this year and kind of just walk the floor and look what sees it, look what is interesting to us, and
Yeah.
whatever we buy, we're out of power right now, pretty much. So we're gonna have to factor in a shop move as well,
Oh,
and
geez.
yeah, it's gonna be a nightmare. Like we have stretched the limits of our space and power to where we are right now, and we'll see what's next.
Yeah. No,
But
that's cool. That's really cool, though. Yeah, it's always exciting, and it's so much. People underestimate how much work it is to like do your research well and get a machine. I feel myself dropping the ball all the time. Like I should have gone and used a Fanuc control, but in the end, it's still a great machine. So you can only complain a little bit because it gets the job done and it does it well.
yeah,
Yeah.
and Fanuc is dead reliable. Like it might not have all
Yeah.
the bells and whistles, but like you probably won't ever have a servo drive go out for 20 years or something like that.
Right. As long as you change the batteries, you're good.
Yes.
Yeah.
Yes, you got to make sure to do that. Well, before we get into questions, you mentioned automation. I wanted to talk a little bit about your what you have automated, how you guys approached automation, and all
Yeah.
of that stuff.
We have our everything forward of the op1. So the op1 on all our V2 parts are we put on the work holding that we're going to use in the Doosan, and then we load those onto a block just of material that has like the Vero S, the 0-point clamping pin and its clocking pin, and yeah, and then we bolt all that up, put it into a giant rack, and the we have a universal robot UR10.
Okay.
And it just picks those up and loads them into the machine, pulls them out when they're done. And it doesn't have to be one part at a time. We can run any different combination of parts through, which is pretty nice. And I mean, some of that is because John wrote some software in a little web server, so we can select our parts that we want to run. And so it's fairly fine tuned, and that works really well.
Web server, you can schedule jobs, and then it talks to the UR and tells it where to pick
right.
from, or
and it talks to the Doosan and tells it what program's next.
that's awesome.
Yeah, it is a lifesaver. Holy smokes! So I mean, that thing, you look at our machine shop and you're like, do they do anything? But because it's like never running, right? I mean, the truth is we crank out more machines than we ever have. When you can run, 24 hours a day or run, through the weekend, sometimes they'll set up 25 parts or whatever it fits in the rack, and come in the morning, most of those will be done, and it swaps. Well, it runs like a day at a time. You do about an hour apart. So yeah, Jack,
That's pretty epic.
It is pretty awesome. But so that also leads to like there's we've just changed our working week from only being 1 week on a machine to 4 weeks within the work week that machine can run, which is just amazing. Yeah, and then somebody breaks it down from there, loads it up to go out to anodize, and we ship them off.
Wow. So 2 questions. How do you like the Vero system?
Yeah,
Is it pretty good?
it's amazing.
Okay.
You definitely. So the universal robot is working with it. It has been pretty good. We've had a couple of little incidents that I think the UR10E is only good to 10 kilograms, and like a bunch of our parts are right at the edge of 10 kilograms. And I think that model, or the one we have, is 4 or 5 years old now, probably 4 years old. And so things have probably changed and gotten better, but there was just a little bit of a height deviation when it would set things in. So you could have some issues there just with the accuracy of the robot. And the Vero S module, you have to get everything within about a millimeter and a half, something like that, height wise, for it to clamp in properly. So that's something to caution yourself about, is like do I have the right robot for it? If you're out at the end, if we're like at the end of the travel, we try to maximize the travel and stuff. So you're pushing everything is pushed to the limit on so it's like, yeah, no kidding. You're going to have some failures, but
Right. You're like, hold 10 kilograms at full
oh my,
extension.
right,
and,
right,
and
totally. Here's a part that would kill you if it hit you in the side of the head, but like you expect it to get within a millimeter. After all that talking smack about a Fanic robot would probably be the best option for loading those. But we're doing pretty good with that setup, and the Vero S module it clamps really tight. It holds things really well. It's incredibly reliable. So
awesome.
Yeah.
And then my other question was, so everybody I talked to who has implemented automation or is starting to, it shows the weak points in their process that they didn't know they were going to see. Everybody thinks like, chip management, or like, tool life or something. But like, then there's like, that one corner builds up with chips and, scraps apart every 30 parts. Like, that's the weird stuff. So I wanted to see, what weird stuff has automation shown is a flaw in your process, and how have you corrected it?
Yeah, chip buildup is for real. It was really bad on the UMC 750, and it's like the UMC 750 gave you so much room. Like the inside of the machine it has a lot of room in it, which is nice. It's like a ergonomic thing or whatever, but those corners would build up with chips, and the Doosan, the tool probes always get covered in chips. So all of a sudden your probe will start airing out and stuff, and it's because it can't communicate because it's covered in chips. So that's like, make sure your door has been blasted off. You don't have any chips in there, right? And then make sure the probes are all clean and everything before you start your cycle, so you don't have it stall out in the middle. And some other weak points. Here's one for you. We put the rack with this isn't machine tool related, but we put the rack that holds all the parts on one slab of concrete, and we put the machine on another. And so we joke now that like you have to tune the rack in once in the spring and once in the fall, that like the temperature change and all that, and the ground causes the rack to move just enough that the robot will start dropping parts if you don't. So like you think you have a clamp and you don't, and that if a few times we'll be like, what the hell's going on here? But now we feel like we got it locked down, that we know we're pretty darn sure exactly what's happening. Seeing people out on the floor with like a dial indicator on the concrete, but like going from one slab to another and being like, it has moved, and
wow,
like, it's time again. So the next time we'll have to plan for that, which is interesting. So we're looking at a big machine, DMU 85 with its pH cell.
Oh wow.
The concrete though is like, before we were talking to the rep, and he's like, you're probably going to be just fine with it, being on just a slab that you have there. But now we're like, no way, we'll definitely rip up the concrete and pour in a new slab before we do that, because that would be so unbelievably painful to have to pull that machine out with its cell, then do the concrete while it sits where, I don't know, like outside.
Right. Yeah, you don't want to gamble on that at all.
Yeah. So those are the yeah. I don't know. The weak point thing is for real, and I don't have like too many. I'm saying the exact same thing that everybody else would say. It's like chips got places that I wasn't expecting. But those things are real.
You're the first person to talk about slabs moving. I think we all know that it does happen, but like I would never have thought like, oh yeah, these two slabs are going to move enough that my robot's going to air out. Like it's
like a millimeter, right? And that's all
crazy.
It takes.
Yeah. That's really cool. I mean, it's not cool, but it's a good point of reference, I think, if anybody's listening and thinking about setting up an automation cell. I never would have had that as a thought in my mind of like, oh, I got to make sure they're on the same pad, or I got to recalibrate every so often. So I appreciate that.
One other thing we did for automation is we took all of our tools and we went with like fancy shunk tooling that they have, like the hydraulic holder. And all the drills are, what do you call those? A Tendo, or is it Tendo? No, the Tendo's the hydraulic sleeve. Oh shoot, this is pretty sloppy forgetting this. But anyway, they're like deformed, so it's a and then the Tribos or whatever, and so, and the big thing there was like we kept having people not check tools when they put them in an ER collet, and then they like have run out and problems from that and stuff. And yeah, is it their fault? Uh, yes, and no. I mean, everybody's so busy. They're trying to get everything done, and like you can see how somebody would miss it, or like they'd measure it wrong, or like it's the end of the day, right? But if you get good tooling, it really helps things because it just like sets them up for success, and they don't even have,
Right.
you know. Just on a side note here for people who are listening, like, so we used to use Kennametal hydraulic holders, and they were like $400 or $500 a piece, like $250 if you had the 50% off discount with a new machine. Typically, shunt ones like $200, $250 at normal price,
Right.
right? And then you can get like discounts and stuff from there, so they're actually cheaper. So we realized this after we burned through some a couple of Kennametal holders. We were like, all right, maybe we should switch to the shunk. What does the shunk ones cost? And then we're like, oh no, they were cheaper. We wasted all this money. So, and then we haven't had a single problem since. So, maybe we were using things wrong. We definitely were cutting a little different, but some of those really good tool holders are worth it, and they may not be as expensive as you're expecting, but they can make a huge difference, especially if you don't have maybe somebody who has learned over the years of how to set up tools.
Yeah, it just dummy proofs the whole system.
Yeah, I think so. Right. Yeah. Take anywhere something's going to go wrong, address that area if it's going to happen, especially multiple times throughout the year. Right. Like we know we're going to change out tools throughout the year. So, and we've got 60 something tools in there. So there's 60 something chances at least throughout the year that something's going to go wrong. So
yeah, we haven't quite got the money together yet, but eventually we're going to go fix Power Grip for that reason. Same kind of thing. Is it a lot of money? Yeah. But is it dummy proof in that system so that Brad and I don't have to stress about it? Like, it's worth it, and like shrink fit, I like, but I don't like that, if you scrap a tool in one, you most likely scrap the holder as well.
Yeah.
The nice thing is the collet's not cheap in a PG, but like at least it's cheaper than an entire holder. So, we'll get there, and I'm definitely looking forward to not having to worry about ER collets, slipping or run out, like you said. So I completely agree.
They definitely have their time and place, though. Yeah, I don't want to also poo-poo those things because there's that's how we got started. A lot of our tools still run on those, and we don't have any problems. And I think a lot of these, like Mari tool and stuff, the effort they go through to make a good tool holder shows, because I don't think we've of like, I don't know, maybe the 100 tool holders we bought from them or something like that. We've had zero issues, and they all do great. Really what it comes down to is you get these collets that are made overseas, right? And that's the only area you seem to ever have problems with is the collet. So it's still a great system. It's just, I feel like the pitfall is user error and so some of those darn foreign collets.
Right. Oh yeah. Yeah. Well, and like these, fantastic systems like Power Grip and Tribos, they have their drawbacks too. Like I don't know about Tribos, but like Power Grip, you have to use H6 shank tolerance tools or better, and then they have to stick out a certain amount. Like that was one thing. We bought Power Grip at my last day job, and like one thing that was never communicated to us until we had a system was that you have to bottom out in the collets. So and like they have an adjustment screw, but that adjustment screw only goes so far. And that means that sometimes you got tools sticking way further out than you really want them. And sometimes, you've got the gash of a tool or the just at the end of the grind, just inside the collet, which sucks.
Right.
So stick out can be an issue with systems like that. And I don't know if Tribos is like that, but it was one of those things.
No, they are. Like, just literally yesterday, I was like, I need this 1.5 millimeter drill. So where I'm working on the porting, doing a better job with the porting on the trunnion. So, we're trying to build all the automation into the new machine. And so I'm trying to use this 1.5 millimeter drill, like way down in this hole. And I was like, I got just the right tools. I went and bought the shank holder and everything. And I got the 1.5 millimeter drill bit I needed on order. And it's like 2,000 small, right? The drill bit, the shank. And that thing is just a slip fit in and out of the holder I got. So I don't know what I'm going to do there. I got to figure that out. today or tomorrow or next week. But I'm like,
Right.
dang it. Like the simplest thing, all I have to do is clamp down this tool. And yeah, that's for real. You have to have tools that are, yeah, like you said, that H6. But that also was never communicated, with me. Those are things that, get better all the time. People, like that's one thing I love about the instant machines community or whatever. It's like, all these people giving you such expert tips on things, on how to do, like how to what you can really count on these tools for. So
Right. Yeah.
yeah,
Because
yeah,
like a salesman, I don't think is going to lie to you, but they're obviously going to demo it in the most ideal situation. So they'll bring an end mill that fits perfectly in the collet and looks like if works perfectly with power grip, and then you take any of the tooling that you normally have, and you're like, oh, well, I got to order an extra, like a custom length of this so that it actually sticks out
yeah.
what I need or something. Right. Okay. But I
And
mean,
a lot of salesmen have
great.
never even used it, right? Like
Right.
they literally don't know. So it's not even on their radar. Yeah.
Well, you mentioned your new machine, and I think literally all of the questions we got, except for one, were about the new machine. So let's dive into.
What was the question? Wasn't about the new machine.
Well, was it just a comment? A wannabe machinist said, "Thanks for getting me into the trade. The Pocket NC was my first real piece of CNC equipment."
Oh, yeah, right. I saw that. That was pretty cool. Yeah. It reminds me of the Bridgeport, right? Like people use what they got, and that's cool that somebody used a machine that's very small and not very sturdy to like really take it further. That's cool. Yeah. So new
So I
machine.
guess the first, well, let's go with, so from the Patreon, David Ron asked, he had a couple questions about tooling. So why did you choose Shunk for the Platinum?
Yeah, it's what we used here, right? So we had switched over to using the Vero S modules for our 0 point work holding, and I was thinking about it when we were sort of early in the design stage, and it seemed like people are gonna, if they have a table with T slots, they're gonna just mount some sort of work holding to it. And for anybody who values their time, they're gonna maybe you don't reckon. Maybe it's not quite a fair thing to say, but once you use some 0 point work holding or some sort of quick change thing, which they're all getting amazing, by the way. Like we just happen to use that one, but I don't know, Lang's is amazing. I think Fifth Axis has done an amazing job, and like all these things they're just impressive. But this is the one we were familiar with. And it made such a change. We're like, why are we going to put a table on this to then bolt on, a Vero S module? And then, so we just naturally wanted to build it in. And then we also, it was a huge struggle with the UMC 750 to figure out how we were going to port the air to the automatic vise. And
Right.
what we ended up doing was, are you familiar with those like tubes that have like the coil of tube in the center? It's like you push the connect fittings, and then like you put the tube in both ends, but it's just got this like long stretchy coil of tube, like you'd see at like a oil change shop or something, but it's really small. Anyway, yeah, so we ran two of those to the vise in the center, and we just had like a thing that was like, do not ever run this more than 700 degrees or something on the C-axis. Otherwise, it would just twist those things right off. And so we knew we needed through table, because there just wasn't an option on the UMC 750. I mean, it was kind of before anybody was doing 0 point work holding there. Anyway, so yeah, we knew we had to port that in, and it's nice because those modules are designed to be used with air, or at least they make ones that are designed to be used with air. So that was great. Yeah, it just made sense on a lot of that front. And then there's vices and stuff you can get off the shelf that fit those, and they're only coming up with more. And then you can put pallets on it and stuff like that. So it seemed like it would set people up for success, if nothing else, just to be able to change out their vise or their fixturing fairly quick.
Okay, that makes sense. And then his other question was, why did you go HSK over something like ISO 20, which seems to be more common in hobby machines? Was it availability of components, or just, full send to get the best you can?
Yeah, I didn't see a lot of like ISO 20 holders, like different types of holders for that. Whereas the HSK, while it's still pretty limited too, it had significantly more. Like there's some crazy small boring bars that are made by Big Kaiser. So that will be nice. And then, there's some really good holders from Tribos and stuff. And you can still buy the ER16 holders, and you can get, I think there's some ER11 ones too. So there was more options there. And then with the high RPM, originally we were going to be 40,000 or thereabouts. We'll probably offer two options, an 18,000 and a 40,000. But when we're looking at the 40,000, there's a lot of stuff out there. It's like, well, these tiny, tiny little drawbars that are pulling on these pull studs, there's not a lot of clamping force there. And the more you research it, basically, like if you look at the HSK, I think it's Kennametal that gave a good presentation on it. But if you look at HSK versus Cat 40, the HSK is kind of like I don't know if you're familiar with it, but like the big plus design where you get the dual contact face. Yeah. And that's really nice because with Cat 40, you see like a lot of change in height from spindles warming up and cooling and stuff. And then it also just like messes with like, you get that hard pull out, like that big boom when the spindles gotten really warm and then it's cooled off. So it seems like that's hard on the system. Like the tool changes just aren't as smooth, but like above all else, you get a stronger clamping force the faster the spindle spins because of the way the drawbar mechanism works. And then also when you look at the contact, you end up with like another 50% more contact area over the cat size of the equivalent. So just, you have more rigidity there, more tools, and it's better in high RPM situations. That's my opinion. I'm sure on any one of those points you could be like, yeah, but personal preference maybe.
I did a poor job. Let's set the stage for what this new machine means to you guys and what it is, because it is a pretty big departure from your guys' normal machine, both in size and price, everything under the sun. So what is it? What do you like? What are the specs so far? All that.
Yeah. What is it? With the current machine, I even found myself not using it very often because my time is just so limited. So I'm unnaturally going to be drawn to a machine that I can get things done fast on, right? Like, same thing for you, Dylan, right? Like, how many times do you grab the Pocket NC V2 to go make your parts at work, right? And it's a great machine. And if you're bound up on like getting things, like if you don't have access to machines or you're doing prototyping at home and stuff, it could be a really good fit for you. But when you have it, the more tool you have access to, right, the more machine tool you have access to, just the more productive you can be with what little time you have. And so here we are with a very small portion of our users actually being hobbyists, but professional users. And
I think would be surprising to most people listening. Like I would have never guessed that. Looking at the machine itself, I would have thought, okay, this is probably mostly schools or hobbyists or something like that, and definitely not research labs.
Well, yeah, and then like a lot of those schools, and there's a lot of school stuff for training and stuff, but some of it that school, we kind of put them in one category is also like, people getting their PhD or whatever, and they're doing some research project. But yeah, it kind of caught us off guard too. And so we had all these people that were asking for more machine, that they're in the same boat you are, right? That they have a facility that doesn't have extra space or has power requirements that they are limited to. Not everybody has 220 power or whatever, and so they bought our machine, but they still wanted more, and then like everybody's like, this is not going to be a shocker to you, but everybody's like, we need coolant, and we need a tool changer and like more rigidity so we can in torque and stuff, so we can just get things done, and we need a little bit more work volume. And so we kind of maximized what we could do within some of the machines we had here, and this is sort of what we came up with. Yeah. So as far as like, what is the machine? The machine is hopefully something that like I'll want to use personally. Like, I've been trying to design it as if this is something that if it was sitting next to me, I would use it to prototype or make small parts. And
What are the travels?
not
You already
much.
said it's an HSK. Is it HSK? What size is the
E25.
spindle? Okay.
Yeah.
And then what are the travels going to be?
So we designed it for 6-inch cube, which means you have a little bit of travel on every side more than the 6 inches. But it kind of depends on what you're doing. Just like our IMTS demo, the fixture and the parts are like 10 inches tall and have a diameter of like over 8 inches and stuff. So I mean, there's extra room in some different. Like I think in X, the max travel is. I'm gonna get this wrong. It's probably more than this, but I think like 9.5 inches or something like that. Maybe it's.
Oh wow. Okay.
I need to double check on that number. You'd think I would know this, and I don't off the top of my head. I'm sorry. But and then Z somewhere over 6 inches, like 7 or something, and then the y-axis is also about that. So somewhere between 6 and 7 inches, probably closer to 7.
Okay. Well, and it actually you answered a couple of the questions both Denzel Makes and Murph's Machine were asking about timeline and will there be one at IMTS? And it sounds like you guys will have one there.
That's the plan. So you have to ship, right? So it's like right now it's go time that everybody is putting in their best effort to get this thing out the door, and it's still going to be just like a little bit hacked together. We call it the one right now that I keep posting videos of. We call it the Alpha 4, and then the next one, which should have a little bit more complete anodized look to it, it's going to be called the Alpha 5. But then we're going to switch into the beta machines, which will have a few different structural things to them, and we kind of hope to have those to. I'm gonna say like end of the year is the goal there, and then
I mean I think anybody who's worked on a large project knows that you can have the best intentions of a timeline, but like you don't want to release a bad product, especially something like this.
Yeah, for sure. And for the price point too, it had better work. I'd be ticked if I bought something. I mean, I'm ticked when I buy something for $50 and it's a stinker, so if it's going to cost more than that, it better work.
So let's talk about price then. What is the estimated price right now for the machine?
The goal is 60 to 70K. I'm not sure what beta people will get it for. I know Michelle will try to give it to them for a really good price because nothing's proven and it's the first set of machines, so can't say there. But yeah, the goal is 60 to 70K, which I think is it's expensive. Don't get me wrong, but we're trying to cram so much in this. Like we haven't been cheap on anything. We've really been trying to put our best effort into quality. So I do hope it's a win for everybody that puts their hands on it.
Definitely. Well, so this is one question I wanted to bring to the episode, and this is just an external view, is it seems like you guys have had a little bit of feature creep when designing this. And and this is not like a negative. It's just like I had always thought that it was going to be a little cheaper than that, 40 to 50.
Yeah.
And then it just seems like, oh, now there's like this new thing, and now there's Gorilla Glass, and now there's this. So
okay,
is that something that you guys have been struggling with, or has this been the plan the whole time, and it's just you haven't gotten to that part of the prototype for people to see it yet?
Designing for me is like a drug addiction, right? Like I cannot help myself, and Michelle helps me rein it in. And yeah, I think she'd be sitting here like, yeah, you need to get together a little bit. And she does get mad at me for price stuff, which is like it's a real problem, right? Like you could basically go off into infinity, right? Designing the perfect machine and just making it more and more expensive. Okay, Gorilla Glass. I'm going to explain myself there. So when we got our first mini mill, which still runs, by the way, and it's like we always joke that machine you couldn't destroy it because anything on it is replaceable and at a decent price, right? But it came with plexiglass on it, and so it was like within 6 months you couldn't see through it. It seemed like from all the chips hitting it, and then the UMC 750 wasn't much better. That it has like. While it can take a tool hitting it hard and like a bullet, and it not break, it still would get to the point where you couldn't see through that glass, and we had to replace the glass on it. So I never even, to be honest, looked at or considered regular glass for it. I was pretty adamant about the Gorilla Glass, but It wasn't that much more expensive. When I was talking to the glass manufacturer. This is the same. Are you familiar with the International Space Station? Like a little bit, maybe.
A little bit, yeah, yeah.
Yeah, so you know that there's like this window that like you can see out, and it's got all these. You can see, same company that built those windows for the space station, but it was a little bit of a draw. But they were talking about the cost of glass, and they're like, yeah, no, the Gorilla Glass isn't all that much more expensive. It's going to cost you an extra 20%. Which honestly, the windows aren't all that expensive. They're not cheap. They're not that bad.
I mean, it looks cool. Like
Yeah,
it looks like a
thanks.
spaceship now, like with all that put together. It looks
Yeah,
fantastic.
thanks. But I wanted windows that were like unlikely to break, and we're gonna hold up to the test of time, right? Like you spend all your time, squinting into a machine and trying to make sure you're not gonna break it, and it's like the least you can do is make sure the windows are gonna be, see through. So that should hold. It's like I'm not sure if you're familiar with Gorilla Glass, but it's like
Yeah, it's on my phone.
yeah, right, and it doesn't scratch hardly.
Yeah.
I mean, you can scratch it, but it's like compared to an iPhone 4 or something like that. God, it's amazing. It's unbelievable. So yeah,
Yeah, I think I watched a video on how they make it too, and it's like insane. They're making like
yes,
almost like a Prince Rupert drop, but in a flat plane to put on your phone. It's
yeah,
really cool.
it's unbelievable. Yeah, and then I don't know. Like you could say that putting on the Vero S module is also a little bit of that. Like okay, it's not going to fit everybody's needs, and porting the air through and all that. But these are like there's just going to be people coming back to us in a few years being like, because we really in the future we really want to release this with a robot or release a robot for it. That's why the door is automatic and stuff like that. And none of these things were actually that expensive when we put them on our machine for automating our own stuff internally. But the time it takes to like modify things is just frustrating, right? Like all these people who have great ideas and they want to go out and make them and stuff. It's difficult because you have to make sure like, do you find a job shop or do you make it yourself? And like, okay, if you're standing behind a machine with a part that you've already proven for the 50th time and you're sitting there changing it by hand, that's difficult. So you want to go and automate it. Guess what? The learning how to use a universal robot, even as simple as they are, is not totally easy, so trying to make some of that easier for people with what we've learned. We can do it now or we can do it later, and so there's a little bit of product creep there, right? And
so was this about the price point that you were anticipating from the beginning?
No, I was hoping I was hoping 30 to 40,000, and with a V1 I was hoping we could sell those machines for $1,000 too, and it ended up being it's just expensive to make this stuff. You have to have enough margin to provide really good support, and you have to the problems kind of go off into never land, and you're just trying to figure out how you can always improve things. Like we still release software updates all the time for the V2 that are just like crazy improvements, right? But in order to do that, it does take some money. So and I maybe someday we'll figure out how to make things lower cost, and you can do things in scale and do that. But there's also just not that many people buying machines, and like there's machines, small group of people.
Yeah. And I think that knowing now that you're targeting this at your main user group, which is not hobbyists, like I think a lot of us anticipated, it makes a lot more sense. Because I was talking to somebody on the Discord about this, and I was like, well, maybe, this is for shops that would buy like a Datron Neo. Like that's not a cheap machine either, but like if it fits in your room, your clean engineering office, that kind of makes more sense. Like I'll spend a little more to have something that works in that environment. So I can understand it for sure.
Yeah.
What you mentioned software, what's going to be the control on this? Because you guys use a BeagleBones and Machine Kit on the V1 and V2, is that correct?
Yeah, and we're calling the new, so it's kind of like a branch from Machine Kit. I'm not a software guy, so take this with a grain of salt. But so we use the BeagleBone because of computing power that's on it. It's got a lot of real-time control stuff, which makes it great and unbelievably fast in some areas. Like pulse generation, or like it's called these things called PRUs, and they're incredibly fast at looking at signals and processing signals, and way faster than you'll ever get with a Windows computer, and so, or at least from my understanding. Anyway, and then we've got our own kind of interface that we're calling kinetic control, and it's still a work in progress, but we're trying to do kind of what Haas did, right? Like bring a lesser number of button presses and more functionality, and provide it in a way that makes sense to machinists and helps them with all kinds of features that we're excited about adding here in the future. But some of that is only possible if we can control the interface. So, like for instance, we had to write our own. I had nothing to do with this, but the TCPC, right, and the tool center point control and dynamic work offset, and those were only possible because we were using Linux CNC, which we could write our code for. But if we were using somebody else's software, like we could put a FANUC control on the machine, but we'd be at the mercy of what they had time for and working with their software engineers. And in some ways, it's just easier to do it yourself if you Definitely. Have the right people.
Yeah, for sure. So what's the hardware that it's running off of this time?
Computer-wise?
Yeah.
It's also a BeagleBone, but it's a newer BeagleBone. So it's called a BeagleBone AI. So it's like a quad-core quad-core processor, and it's got more PRUs and more bells and whistles.
Very cool.
Yeah, it's nice, and they've been, and the people say BeagleBone. Really, what it is, it's just like this group of engineers at Texas Instruments, as I understand it, that just kind of like held what they did hostage, and they were super passionate about making a computer that was similar to the Raspberry Pi, but they wanted theirs to be like all this real time stuff and have some features that were really great for robotics, and so it is incredibly good at that. I mean, it's really just a Texas Instruments piece of equipment, and it's called the BeagleBone.
Okay, very cool. Let's see, we got a few more questions. What is the tolerance that you're aiming to hold with this machine? That's from Denzel Makes.
That's tough. So we'll give people, I think when we get closer, we'll give people really good information on that. On the Beagle, or on the V2, we said this is great for work that's like plus or minus 5,000s. It's tough because it's using stepper motors that you don't. There's a lot of reasons why it can be outside of perfect. And like we went through this non-nuclear proliferation stuff, and the FBI came and it was super intense. And they made us do like all these calibration things on the V2, and some of the numbers we got really pushed us into that direction, because it would be incredibly accurate. But these are like under no loads, and like without a bunch of debris on it. And so like in this ideal scenario, you have a machine that's far more accurate than it is in the actual machine case. So we've yet to really prove that. I mean, I think the goal is to have it be very similar to like Haas Mini Mill, with its accuracy. But we're still writing like probing routines to check parts and stuff, and it's going to take some time before we can really nail it down. I feel like that's such a sheepish answer, right? Like I'm just trying to dodge the question. But
that's totally fine.
I make stuff all the time that like plus or minus 1,000th of an inch is within the spec that I need, and it would be really nice if people could count on that throughout the whole working volume. But we'll post some actual real information at the time before people are committed to buying machines, so that they actually know what they can get. We're not going to be out there saying, oh, it's got a resolution of 30 millionths of an inch, because that does nothing for you, right? Like, right. Oh, but it's not square within a mile. So
right, yeah. I think a lot of people don't really inherently understand the difference between linear accuracy and volumetric accuracy, and especially on a 5-axis, that's when things can really go off the rails. It's like, oh well, yeah, all the axes are good, to within 0.2, and it's like, yeah, but it's not square, and it doesn't have any comp, and it's garbage from point to point in 3D space.
Oh my God, compensation. You want to talk about that for a minute?
Yeah,
That's
well, we had one of the questions from Kara Curry PGH was about how did you map the thermal comp to do the cooling channels and all of
yeah,
that. So
right.
let's talk about all that, because that's a big thing.
Yeah, we put the cooling channels try to follow the rail beds on those, keep the rail beds, but then we also go perpendicular to the rail beds in some places. For the most part, we were fairly pinned down on where we could fit those cooling channels, just because of just where everything is, right? Like there's only so much you can do to place things, but really try to get them under those rail beds and then perpendicular to them. So like, for instance, the frame is like a giant square with a big hole, a big square cut out of it, right? And we know that those there'll be vertical growth pulling the two rails apart, and then there'll also be growth along those rails. And so trying to reduce that as much as possible, we think will be a big help. And the reason we went with the cooling, and we're still working on it, by the way, but the reason we want that on the machine is just like, with the UMC 750, with the UMC 1000, we see all these problems that are related to thermal growth. And while you can have like lookup tables and stuff, internal to the machine to do this stuff, you want to minimize thermal compensation, because from my experience, it must be a difficult problem to solve because nobody does it super well, right? The best, I don't do any sports, but the best defense is good offense, or whatever, something like that. Or maybe they say the opposite, but something like that. And so I think just trying to really attack the problem, or approach the solution, the best approach is going to be to try to just get rid of it.
Right. Yeah, I think that all the best machine tool builders in the world start with the best mechanical accuracy they can. And then improve on it from there. But like it's really hard, if you got one axis going out a few thou due to thermal growth, you can only do so much at some point to fix that.
Yeah, that problem is real. So then, to kind of segue into the compensation areas of it, that is complex. So John's working hard on this one, and he won't let us down because he's just not a quitter. But so we figured there's like 15, just as like a standard compensation, there's 15 levels of compensation that have to happen just for the 5-axis, just as a starting point. So if you imagine you've got like one linear axis, right, and it travels, that it has to be compensated for in X and Y. Right, it's not going to travel straight, with the exception of you can choose one axis. Like you can choose your x-axis and just say it's straight, and everything else is going to be put in line with your x-axis. So for the other 4 axes, you have an x, y, and z problem. That it's not going to be perfect in z, and it's not going to be perfect in x or y. So you build up a whole bunch there, and then all of a sudden now you've got some thermal compensation, right, which is weird. And then you have a layer of like deviation in the straightness. So it's not like the compensation, it's not like you can just say that any given axis goes out indefinitely in space, and with this angle, it's going to go out in space and it's going to change in X and Y. So you have like these lookup tables in X and Y and Z for any given point. And then like you have, the same problems with rotaries, and it's a lot. And now you do like TCPC. So now you have to do all these translations, and then you have to translate them with TCPC. And it's like, oh God, so it's, I don't know how many, it's beyond me, and it's a work in progress, but we are definitely kicking some butt in that area. So like John was just doing he was doing some compensation stuff the other day with the tooling ball. And I'm going to get his numbers wrong, damn it. I want to say it was like with compensation, he was seeing repeatability within like a half a micron or something like that too. Yeah, I think it was like to the point where you're like, okay, yeah, those numbers aren't real, right? Like they don't mean anything. You start breathing on stuff. It's so the compensation is possible, and we can see we can actually compensate for things, which is cool. So now you have to like, once you can see that you can provide compensation in certain areas and improve the machine's accuracy, now like you have to apply that to all the different levels and test it and stuff and cut parts and check to make sure they actually came out square and, put those on the CMM and try to get real information there and check your work. So it's a process for sure.
Oh yeah, definitely.
But we're going to have good compensation. That's what I'm excited about, which is great because nobody can build a perfect machine. You see it on the best machines, they're compensating.
So what's the backbone of this as far as movement systems? Is it servos and ball screws and rails, or
Yeah. So we're using C5 ball screws. They're not the best. They're not bad by any means. They're ground ball screws. So they're made by, I think we tested both NSK and THK. So they have a deviation. I'm also going to get this wrong, but like, I don't know, 1 micron or something over a meter, or, so it basically low enough that that is not going to be the problem in your compensation tables. And that it's nice because those do give you, per raisin, per degree, what your compensation is linearly over a meter. They're super nice. And then the servo motors we're using Technic servo motors, which is amazing.
Which is ClearPath, right?
Yeah.
Company?
Right. Yeah.
Okay.
So, so they make those ClearPath motors, and they just really have their stuff sorted. The more you use those motors, the more you become, or at least the more I'm impressed. Like, so we can see all the increase in torque for like at any given time on the motors and all that information, and it's so accurate. We were the other day we were like, where is it? We were getting like a torque ripple. We tracked it down to, we were getting it 4 times per revolution of the motor, and it's just like an insanely small increase in torque. And but it's important because you don't want to have harmonics in the machine when it travels and everything, and rapids. And what it came down to is the motor coupling we're using. So we're using a really nice motor coupling, but it has two axes that it can pivot on, right? And they really nice coupling, but you could see when it would go through this like plane, it would just have a tiniest, ever so small amount of binding, and you could watch those ripples.
Oh, so it's like it's like racking as it turns, kind of thing.
Yes, but you're like, what is this? This is not perfect. What is this? And that's what it came down to. So they've been amazing motors to work with. The people are brilliant, and I think it's gonna really help us in that front. And then for like the rotary axes, they're harmonic drives. So the cycloidal planetary reducers,
right?
51 reduction. They're 0 backlash. They're great for this machine. Maybe we'll do something different in the future, but they're the built-in bearings and stuff, so they're pretty dang good.
Yeah, well, that's basically what drives your UR. I think those are all cycloidal joints.
In fact, for a long time, it was really hard to get those because Universal Robots was sucking up all of the the production of the capacity of the company harmonic drive. So yeah, that was a tough time. It was going to be like 30 weeks before you could get a first piece.
Right. So are you able to generate enough speed on that for like the C axis that it's not going to be the limiting factor on true 5-axis toolpaths?
It's like 90 degrees a second, which isn't insanely fast, but
it's not bad though.
No, it's faster than what our UMC machines will do. So I think it'll be comparable to that. I know like the further out you go, right, from the center of the rotation, the faster those rotaries have. That's also not always true. Anyway, no, I think it'll be fast. It'll be fast enough for the first go anyway. So
okay, that's really cool. I'm really excited to see it at IMCS. I'll definitely come by and say hi and check out the machine because it looks so cool.
Yeah, we're pretty excited. We're working on you've seen the design of everything's little carabiner compliant mechanism, and so we've been working with him on that's going to be our demo part. We're stoked. So we're gonna try to do as many of those as humanly possible and give those as a giveaway at the show.
Yeah. It was AJ had posted. He was like, "Yes, somebody licensed my design, a machine builder," and I was like, who could it be? And then I saw your post and I was like, oh, that's so cool.
It all makes sense now. Yeah. He was super kind to let us use this design for that. And yeah,
that's epic.
Yeah.
Well, that brings me on to shop news and new things. You kind of mentioned a future purchase,
Yeah.
TNG. When's
Yes.
all that supposed to be happening, and what's the deal with that?
So we've just been sorting out, making sure we know everything we want on that machine. They are a year out on when we buy
Oh,
it. I know. So it's like, you should have bought it a year ago, but at the same time, it's difficult to make sure you make all the right decisions and get all the the right features for what we're doing. Like we damn near pulled the trigger on a DMU 65, but we would have been like a half an inch short on the tool, almost exactly a half an inch short on the for the like the, our drill for our cooling channels. So that would have been gut wrenching. So we're trying to make sure we have everything sorted and right before we pull the trigger. And it's not that like it's inevitable, but we're gonna get there with an automation cell for it. It's just all a ton of work, and right now IMTS is the big priority, right? Just making sure we have something to show for that. And then I think as far as shop news goes, we picked up a CMM that we're trying to improve our calibration process even more for the V2 line. So we're still always improving that, and we're trying to automate the the calibration and just improve the quality there. We
what'd you get?
also Krista Apex. I don't know the number off from the top of my head, how big it is.
But a Mitutoyo.
Yeah, and it's got the 5-axis probing head, which is nice and super fast. And we actually had to buy an older generation one, so that was more hackable for the software guys. The new Mitutoyo ones is Mitutoyo's own proprietary control, and the old ones use this thing called UCC server, which is like an I++ communications protocol, and they can manipulate to get to do whatever they want. But so if you bought a new one today, you'd better start looking at retrofits. So,
Okay.
I mean, if you want to do what we're doing, that's where you'd be at. And then we got some better equipment for our pick and place line. We got a solder jet, which is cool. Yeah. But the news is we're just cranking away at trying to be ready for IMTS and put on a decent show. We're gonna be right next to Bantam Tools. How cool is that?
Oh, awesome.
Yeah. Brew was like, we should do something for IMTS together. And we've both been super busy. But in the end, he was like, you guys should be next to us. And that was a long time ago. I think that was the last IMTS. And so whoever got our booth got us right next to them. So it was fun.
That's
Very
excellent.
excited. Yeah.
Well, I think we will all come check you out and then see the new machine, and it's going to be really cool.
We're like off in the corner, right? Like we're in the bathroom, like one of the stalls. So we're in stall number 5 in the men's room.
Well, your machine would fit,
It's perfect.
It's a nice,
yeah, right.
Yeah, perfect.
Plug in near the back of the toilet. Yeah.
Well, that brings me to the last question I ask every guest, which is, what did you research this week? And it can be machining related, it could be anything under the sun, but what's been popping up in your search browser?
Vices. I've been looking at small work holding for the show IMTS. So there's actually not. I mean, I shouldn't say there's not a lot of vices that are in the small realm. There are, but ones that fit our need. And so I've been kind of looking at shunks and stuff.
The KSC Mini, or
yeah, totally. So those guys are very nice. They're giving us 6 of those for the show.
Awesome.
So I know they're so nice. They're very good to us. But it seems like their products are all great. And anyway, and small tooling. It worries me that like there just won't be. This is what I've been researching: tool holders and collets. Like, you look at doing all these like long tools and these special applications, and we need more like. What we really need is a 12 millimeter hydraulic clamping tool holder for the HSK E25, because you can get sleeves that are 12 millimeters that go down to just about any size, and that would be a cheap thing. But then also like extensions, a lot of the extensions are in that half-inch 12 millimeter, and so like for people to be able to like really reach these tiny little areas, I mean, you're still using small tools in a lot of applications, and a lot of those tools are 1.5 inches in length, and they're not going to grind it on a 5-inch piece of carbide, and if they did, it would be super expensive. So I've been trying to figure out. I'm trying to put together like a big list and catalog of all the different small things that fit our machine and fit, these small, any of these small applications for people. But I'm also researching, who can make them. There's companies all over. Diebold makes some really great stuff. There's LAIP out of Spain, and Shunk makes a bunch of their stuff out of Germany and stuff. A lot of it's, obviously European. There's still a way to go on for people to actually have everything they need. It's like the same problems, right? That everybody else has, like, the hell kind of tool holder do I use for this, job? I got no clearance on anything, so I can't use a call it. Yeah. Or call
Does
it holder.
Tribos make a extension? Like
They make some small stuff, but all their extensions are 12 millimeters at the base or half inch. And so, but they don't make a HSK 25 12 holder, and nobody goes over 10 because they're afraid somebody's going to put a 12 millimeter end mill in it and just wreck the spindle, which is a legitimate fear. So yeah, just like everybody's always pushing the limit of what they can do with their machines. Darn people. Like if you're one of them, and I'm one of them, and yeah. Anyway, so
yeah, machinists are the best. We're the best in the world at wrecking stuff.
Yeah, that's what what did you say at the beginning of the show? You said we're good at finding the breaking point of.
Yeah,
that is the story there, right?
Yeah, you tell us it's a 10 millimeter max, and we're going to say, okay, but yeah, what about a 12?
Yeah, right.
What if I'm really light on a 12? Like,
yeah, 11.1. Can we do that?
Exactly. Yeah. Well, Matt, I really appreciate you taking the time to come on. It's been great to get to meet you and talk about the new machine and everything Pocket NC. Thank you so much.
Yeah, thanks, Dylan. It was very kind of you to have me. Honestly, I was like, oh, no ways. I was pretty stoked when you asked. You got a pretty awesome show, and you got some people on that actually had some good things to, some real information to share. Unlike myself, I feel like I didn't share any real secrets, but no, I appreciate you having the show just so we can hear cool things.
Yeah, my pleasure. I definitely include you among that list. I mean, like I said, I reached out because so many people had so many questions about your machine, and I really appreciate you, giving us an inside look on what's going on, what you guys are testing. I think that's super interesting, and I'm really looking forward to seeing it at IMTS and where it goes from there.
Oh, cool. Right on. Yeah, no, the Instagram account, I posted that, and like I try to answer people's questions the best I can on there too. I don't love doing it, but we had so many people just like asking for progress reports, even within like our own distributors and stuff. So it became nice to just have that as like a place I could, since I'm not very secretive, I could just post things about what we were doing, and I'll probably delete that Instagram account when the machine's done, to be honest. But it's fun for now to like get to share progress reports with people, and so they can wonder where they're at and not have to be feeling like they're pestering or whatever like that. Because it's cool that people are so kind and are cheerleaders out there, but it feels kind of shitty to just leave some people hanging, when they're so kind. So that's the goal for now anyway. Post material and let them see what the progress is, and then from there, who knows, maybe just delete that account. Yeah.
All right. Well, thank you again. Thanks to all the Patreon members who make this show possible, and thanks everyone for listening. I'll be back next week.